The i-GCSE syllabus contains some differentiation questions. This is one on the motion of a particle. We're given the displacement and we need to find the velocity and then answer a question about that. Let's have a go. Okay, let's have a look at the problem involved here. We've got a particle moving along a straight line from the point O. We're given its displacement, s, in terms of t, and the displacement is some sort of cubic. Now, when a particle is instantaneously at rest, this means the velocity is zero. If a particle is at rest, it's stationary. So we need to find the velocity from our equation for the displacement. And velocity is rate of change of displacement. So we need to differentiate this expression and then equate it to zero. So the velocity is equal to the rate of change of the displacement, so I can express that as ds dt. The rules of differentiation: we take the exponent of 3 and pop it down to be the coefficient and then reduce the 3 by 1. So we get, for the first term, 3t squared minus the second term, the 2 comes down, multiplies the 5, so we get 10t, the 2 being reduced to 1. There's an invisible 1 here. And now the third term will differentiate just to 8. The reason being there's an invisible 1 here. When the 1 comes down, that multiplies by the 8, and then t now to the power 0 is itself 1. So the same process goes on through all these terms. The constant 3 will differentiate to 0, so this will be our result for the velocity. So to find out when this particle is at rest, the velocity here will equal 0. So if I equate this quadratic to 0 and solve it, we will get answers for t when this is true. We could use the quadratic formula, but let's just have a quick go at solving it for ourselves. This would have to be 3t and t. Now 8 could be 8 and 1 or 2 and 4. Let's try 2 and 4. A 2 here and a 4 here. This would give us 12 and 2. Hey, we've hit the jackpot straight away. 12 and 2, I can arrange for the 2 to be taken away from the 12 to create 10. And because we've got a negative 10, this has to be negative, this has to be positive. This should now work out. Let's just check. 3t times t, 3t squared. Positive 2 multiplied by negative 4, negative 8. This gives us 2t. This gives us negative 12t, and yes, if you push those together, we get negative 10t. If this is true, then either this bracket must equal 0, or this bracket must equal 0. So t will equal negative 2 divided by 3. And here the negative 4 pops onto the other side. Yes, we're adding 4 to both sides, so or t equals 4. So as we're told that t must be greater than 0 because the clock starts at 0 and that's when the particle moves off, we can eliminate this answer. So we're left with t is equal to 4, which is your answer.